Greetings viewers, in this video we'll continue with the Cambridge A-Level Further Maths Syllabus Code 9231 Component 1 Pure Maths 1 Variant 3 from the Major 2025 series. And we continue with question 4, I think. So, question 5. So it's a plane equation giving us in this vector form. Okay, and we want to find the Cartesian equation of pi, where, okay, it's in this form. So okay, so let's say we have this a, uh, vector equation like this. What this means is you have one starting vector and you have two of these like direction vector is added. So you can try and sketch it out. I'm not going to draw it like to scale or to exact measurement. So let's say this is the position vector here, right? And so it's going in one direction. Okay, it's going in one direction. So let's say this is the lambda direction, and the other direction going in this way. So actually what it does is it forms a plane. Okay, so it's something like a plane, or maybe I use a different color, okay, to make it more obvious. So it's like a plane, and we want to find the Cartesian equation of this plane pi. So the first step is we want to find the normal to the plane. How to find the normal? So let's say this is normal lah, where it's 90 degrees. So if you can try and recall, to get the normal, you can do the cross product. Okay, you have a cross product on any of these two vectors, you will able to get the normal to the plane. Okay, after we get that, then we can try to do the dot product on any arbitrary point. Let's say x, y, z on the plane. Then we equate that to 0. So then we can get the Cartesian equation, right? So, okay, first of all, we try to find the normal vector by doing the cross product. But we do the cross product on which vectors? So we have these two direction vector here, which we know is forms the plane, and therefore when we do the cross product on them, we will get the normal to the plane, right? So I'll write the normal vector here, n hat. We will do the cross I, j, k, okay, on the first one, 1, -2, -1, then cross the second one, 3, 2, -2. Okay, so we do the cross product first. For the first I component, we cover, -2 become 4, 2 times -1, so -2, so 4 plus 2, 6. For J, cover, so 1 times -2, that is -2 plus 3. So that is 1, but for J component, remember to negative. Then K, we cover, become 2 minus -6. So that's 8, right? So this is our normal vector. So now we try to get a arbitrary point on the plane, or arbitrary vector on the plane, where let's say this is the point, right? 2, 3, -2. And from this vector from this point to this any arbitrary vector, we can call this, let's say we give this name OZ lah. So we have 2 minus x, 3 minus y, -2 minus z. So let's say this is any arbitrary vector on the plane, and once if we do the dot product, n dot oz, it will give us 0, right? So this one is how we finally find the Cartesian equation. So n, this is what we found, 6, -1, 8, multiplied by this arbitrary point or vector. And for column vector, for dot product, you just multiply them, right? So 6 multiply 2 minus x, 12 minus 6x. This should be 12, not 16. -3 plus y, and -16 minus 8z. Okay, so just have to simplify them, and you should be able to get 6x minus y plus 8z equal to -7. And yeah, this will be the final answer for part A. So this will be the equation of the plane in the Cartesian form. Okay, so that's part A. Now we go for part B. This point P has a vector, and we want to find the position vector of the foot of the perpendicular from P to pi. Okay, let's say P is here lah. Anywhere here, or maybe I can redraw it here. So let's say P is here somewhere, and this is the origin O. And then let's say the plane is somewhere here. So 3D is a bit hard to draw, but you have tried to imagine it. So the foot is the perpendicular, meaning when you draw the vector from P to the plane, this part will be perpendicular to the plane. So let's call the foot, we call this F lah. So you want to find exactly what is the OF, right? The position vector of the foot. So first we need to do the OP vector and then the PF vector. So OP we know because we have the position vector of the P. But what is PF? Which is exactly what we found here, right? That's a normal vector. So from P, how we need to go to F is we need to use this normal vector. That will be the one that gets it to the 90 degrees. Right, so OP we know. So let's say this OF vector. So OP plus PF. And we don't know, actually we don't know what is the exact value of the PF, except we know the direction is this one. So we use a multiple on that. So we put the position vector first, then we add the perpendicular, let's say call this direction vector, right? And we add a constant lah, not a constant, variable. So let's say omega. So we travel omega distance to this direction to get to plane pi. Okay, so simplify, you should be able to get 4 plus 6 omega, 2 minus omega, and 9 plus 8 omega. And once we know this is the foot, I mean the vector of the foot, we can just substitute back into this plane equation. Right, so back into the pi, so we have 6 multiplied 4 plus 6 omega, minus 2 minus omega, plus 8, 9 plus 8 omega equals to -7. So all I do is just substitute. This is the x, this is the y, and this is the z, right? So that's the each of the component you substitute inside here. You try to simplify, you can solve for omega is -1. And once we get this value, right? So you can just substitute it back into the foot vector. So yeah, omega -1, 2 minus -1, and 9 plus 8 -1. So you should be able to get -2, 3, and 1. And this is the vector to the foot, the position vector of the foot. Okay. Now, yeah, this is the final answer. We go for part C, and the line L is parallel to the vector, this vector. So this is the direction vector of the line. And we want to find the acute angle between the line and also pi. Okay, so let's say we have the plane again. I don't draw the axis this time. And we have a line. So let's say the line originates from the plane lah. Okay, this line, we don't know what's the angle here. We want to find the angle theta. So let's say I draw yeah, so this represents the plane lah. And if you try and recall, actually we have the equation, right? This is the dot product. Okay, A dot B is equal to magnitude A multiplied magnitude B multiplied by cosine theta. So that's the acute angle formed with the vector and the plane. But the issue is, what is the vector that we want to multiply? We don't know, right? Because the plane, we don't have the vector itself. But what we do have is this one, the normal vector. So again, I sketched the normal vector on the plane here. We already got this normal vector. And since we can do the dot product on the normal vector and the line, let's say we call this alpha lah. Right? And we know that the normal vector is exactly 90 degrees from the plane. So again, I dot this line. So we can just use the relation, so 90 minus alpha becomes to theta. Okay, so first I copy back the normal vector that is 6, -1, 8. And then also the line L is 3, 5, and -1. So we refer back to the formula sheet. We want to find the magnitude of A and magnitude of B. So magnitude of the normal vector, 6 squared plus 1 squared plus 8 squared, and you square root it. And magnitude of L, 3 square, 5 square, 1 square. So you try and type into your calculator, you get square root of 101, square root of 35. Okay, so now we can use the formula, right? N dot L. So we get 101, 35, cosine, and we use alpha lah, because it's not theta yet, it's just the alpha between the N and also the line L. Okay, so we also need to use this column vector here so that we have something to equate. So after you try and solve this and type into your calculator, inverse cosine of whatever this value is, you should be able to get a alpha value of 85.2 degrees. Right, so we did not specify degrees or radians, so you're able to use both. But since we know this is the right angle, then yeah, theta, we can do 90 minus alpha. So you should be able to get 4.8 degrees. So for angle, you can just round up to 1 degrees. Okay, so is this the final answer? Part C. Yep, so we have finished this question 5. Alright, so thank you for watching this video.